Hey everyone. We're going to go ahead and get started. I'd like to go ahead and walk through how you use Google Sheets in order to calculate the relationship between the starting height of that marble or ball bearing as it rolls down the ramp and eventually gets down below and its velocity at the end of the ramp. So to figure this out, I'm going to go ahead and grab this kind of blank spreadsheet here and put in some pieces to help us to go for it. First, I'm going to start recording some information. Know already that what I'm talking about here is releasing at a 5-degree angle. So this is not one of the ones that I gave to you. This is a 5-degree angle for our ramp, and I'm doing this at those 4 different ramp positions, or 5 if you count 0, of 0 centimeters up, um, 20 centimeters up, 40 centimeters up, and 60 centimeters, and last 80 centimeters. So that's where all of this data is coming from, is this ramp of that's set at a 5-degree angle and then dropping the marble down at those different positions. I'm going to start by putting in a title up at the top here, and I'm going to call this column height. And I want to put this height in meters. So I'm going to put a little parentheses after it and put it in meters. Let's go ahead and make this a little bit bigger so we can see it. So maybe I'll put it at 150. That's probably better. The next column over, I'm going to put in speed. So this is speed. And I'd like to do this in meters per second. So I'm going to use an m/s. I'm going to copy down some data that I already had that I took. And the data that I've got from this 5-degree ramp puts me at heights of 0, 0.017, 0.035, and 0.052, and 0.070. So these are my different heights in meters off of the ground that we're dropping the ball bearing. And the speeds at the bottom of the ramp, well, if there's 0 height, then there's 0 speed. And then I've got 0.58. This is in meters per second. So 0.58, and then 0.83, 1.01, and 1.17. So this is what I have so far. These are my heights, right? And these are my speeds. And so now I want to create a graph from this. And it couldn't be easier, but we do have to make some decisions. So I'm going to start over here on the height, and I'm going to click and hold and drag down here to the right. So I've now highlighted all that data. I'm going to come up here to the word insert and go down to the word chart. So I'm going to insert a chart. It's going to take a moment to think about this, and then it'll pop that chart somewhere on the screen. There it is. Now everything is a little bit cramped on here, so I'm going to make my graph a little bit smaller so I can see everything. And I'm going to move my image to a blank space over here. All right, so this is the graph that I've got. I have this amount, but what if your graph doesn't show up all nice? There's suggestions here over on the chart editor, and right now it's come up with this really beautiful suggested graph, but there's all these other kind of things that might show up. And what I'm doing, you'll notice, is that I'm using a scatter plot here, and that's my scatter plot. And if I come across, that's my suggestion. When I come to customize, you'll notice that it already filled in some things for me, like the title of this and the 2 different axis labels. It put height at the bottom, which is what I want, and then speed on the side. And so that's what I want. I could change those here by changing the chart title. And I'm actually going to do that. So I'm going to go ahead and change this chart title, and I'm going to say 5-degree ramp angle. And that's for the 5-degree ramp angle. That's what I have for the height and the speed of the ball bearing drop. I'm going to close that one up, but I want to put in a best fit line for this. And so to do that, I'm going to come down to series. Actually, before I do that, let's make sure that we know how we can make some choices. If I go to setup, you'll notice that my x-axis here is height, which is what I do want. And if you don't have it, you can make a selection here of what you want, but I have height correct. And then under series, There's some choices here as well, and I want the series to be speed. So I've made choices there to make sure that I've got things in the right category. So a scatter chart, x-axis is height, y-axis is, or series is speed. Now I can come back over here and click on series. This lets me change some dots and things like that, but I'm not going to change too much. What I do want to put in is a trend line, and that's a checkbox right here. So I'm going to click trend line. And when it drops the trend line in, it starts out by putting it as a line, a straight line. Now that straight line seems to be a little low here. Well, high, I suppose. And then a little low here. Well, that's jumpy. And it doesn't seem to match my data all that well. So a straight line is kind of in the middle of things, but it looks like there's a little bit more of an arc to this than a straight line can give. And so if I could choose a different styling here. I could choose exponential and see how that goes. No, that's worse. Polynomial, that's pretty good, but to be perfectly honest, polynomials are complicated to calculate with. So I'm going to skip that for a moment. Logarithmic, that's a little bit short on that end. Power series, it doesn't go all the way down here to 0, but it definitely seems to match all the rest of them, like right on. So if I imagine that dropping down, I think that would meet that one. So that's pretty good. And moving average, it's worse. It feels like I'm between polynomial, which again is not exact, and power series. So I'm going to leave this as power series because it definitely seems to go through all of my data there. Now, if I wanted to figure out the relationship between these things, I'm going to go down a little bit further and I'm going to turn on my label. And right now I have no label for this. I'm going to click on that and I'm going to use equation. And that's going to put a little equation for my best fit line right up here at the top. And what you'll notice is what it says. It says 4.37x raised to the 0.496 power. I'm going to close this piece here. The x, what does that relate to? Well, it relates to the height. And the relationship that we're talking about here, if I was to kind of come over to the side and kind of write in the relationship is that the speed, right, is equal to this 4.37 times x, which in this case, x is the height, raised to the 0.496 power. This is the relationship. And if I want to, I can actually calculate anything I want now based on the relationship that I've got. If I was to say, hey, what if I had a ramp height that was in between the 20 centimeters and the 40 centimeters? What if I had like 30 centimeters? Well, to do that, I can actually go ahead and figure that out. I'm going to use the calculator in here because it's a little easier for me to do. And so I'm going to say, I'm going to find my speed. So I'm going to say equals. I'm going to put in the 4.37. And I'm going to multiply that times this new height, which is, I'm going to put in as 0.3 because that's somewhere in between. I'm going to raise that to the power of 0.496. And then I'm going to hit enter. And what that does is it gives me an answer. Now, the answer that I've got here, if I've typed that in right, 4.37 times my height of 0.3 raised to the 0.496 power as a whole. Oh, I know what I did wrong. I was like looking at this going, that seems really high. And the answer is it is kind of high because 0.3 is a higher height than any of those other ones. Right now, my heights have been 0.03. So let me go ahead and put in a 0.03 instead. This seems like it'll match up a little bit better. That's, again, 3 centimeters off of the table. All right, so that looks better to me overall. And the reason why I paused for a moment is I was like, man, that number was way bigger than all the rest of them, but I thought I was choosing a number inside the heights, and I wasn't. So here's what I've got. I can actually add that into my table over here if I want to, where I can put in a height of 0.03 now, because that's what I've chosen. That's better. And my speed is this number over here, which is 0.77. Now, it shows up right on my graph, and you'll notice that it matches right on my line, which is exactly what I would expect to happen if I have this relationship and I'm plugging in a new value. So it's got this perfect relationship where my speed at 3 centimeters up will be this 0.77 meters per second. I'm not asking you to do this last piece here, and I'll go ahead and delete that. I do want you to find what the relationship is here, which is given right up here at the top for our process. So I can take this now and I can select it, and I can come over here and say copy, and then I can paste that directly back into my Google Doc where I'm ready to go. So hopefully that was helpful, and I'll give you any other pointers you need during office hours. Come on in and see me, and we can sort your stuff out if you have any questions. All right, everybody, we'll see you in the next one. Take care. Bye-bye.